In this video, we will learn how to write the electronic configuration for atoms. So we want to write the electronic configuration for nitrogen. So the first step is to go and look for it in the periodic table and find out what is the atomic number which is above it. So this is the number of electrons that nitrogen has, and this is our main thing which we will be using. And we completely ignore the molar mass, so just leave that out. And now the next step that you need to know is this table, which is the electronic configuration table, and it starts from 1s, 2s, 2p, s3s, and so on. And the way that you want to cancel this out is you start from the top, row by row, and you go from right to left. And what I mean by that is 1s will be used first, and next is 2s, next is 2s, 2p, and 3s together. The next is now 3p and 4s, 3d, 4p, and 5s. And normally you don't need to go this much down, because the number of electrons is way less. So normally you just stop over here. Let's just continue for the sake of it, if you just want to understand the concept. So 4d, 5p, 6s, and then the 4f, 5d, 6s, and so on. You get the idea. So this is the way that we go down. And the other thing that you need to know is that S can contain 2 electrons, so 2 electrons, and P can contain 6, D can contain 10, and F can contain 14. So now let's start writing the electronic configuration. So the first is 1s, so 1s, and an S can contain 2 electrons, so 1s2. And now the next is 2s from our table, so 2s2. So now we have used up to 4 electrons, and we have in total 7. So what is 7 minus 4? We are left with only 3 electrons, and P can contain 6, but we only need to use 3 more. So this is how we write it now. So if we count these electrons up, 2 plus 2 plus 3, this gives you a total of 7, and this is the final answer. Let's do another example for boron now. So first step again is to find the atomic number, which is gonna be 5 for boron. And now let's start from the top. 1s can contain 2. We need to use 2s also, so 2s2. And we need to use, we have one more electron left, so we need to use 2p1. And if we again add these up, 2 plus 2 plus 1 gives you 5, and we can use that to recheck your answer. So let's try the example for aluminium now. So you can pause the video and try to do this yourself, and I'm just gonna start with it now. So aluminium has the atomic number of 13. So 13, we need to fill 13 electrons from our orbitals. So let's start again with 1s. So it's gonna give you 1s2. We need to use 2p now, 2s2, 2p6. And now if we count, we have in total 10, and we are only left with 3. So what is the next orbital after 2p? So it is 3s. So 3s2. And now we are still left with 1 electron, because this is a total of 12. And we need to use the next thing. So after 3s, it is 3p. So it's going to be 3p1. And so let's do an example for Fe now. So the atomic number is 26, and we know that the number of electrons are 26. So if we have Fe2 plus, that means there are 2 more protons here. So that's gonna minus 2 electrons. So this is gonna be 24. So also, whenever you are doing an ion, meaning that there is a charge, it's always best, not best, it is mandatory that you do the parent atom first before doing the charge. So Fe is going to be 1s2, next is 2s2, next is 2p6, and now we have 10, so we still need more, so it's going to be 3s2, and next is 3p, so 3p6, and now we have a total of 10, 18, so we still need more. So next is going to be 4s2. I'm just going to move this to the right so we have more space. And now the next after 4s is going to be 3d. So d can contain up to 10, but we only need 6 more. So if we count this again, so 10, and this is 10, and this is 6, so 26. Now, if we want to write the electronic configuration for Fe2+, we always want to remove the electrons from the highest energy level, meaning the 4. We have a 3 and a 4. So here, we only need to remove 2 more, and it is perfect that there is a 4s2 here. So for writing the electronic configuration for Fe2+, the answer is going to be the same thing without this. So if I write it right now, 2s2, 2p6, 3s2, 3p6, and don't write this, and 3d6, and this is the final answer. So here, if you were to write the electronic configuration without writing the parent atom, you will probably get till 4s2 and then 3d4, which is wrong. So you always, whenever you have charge on the atom, it's an ion, so you need to write the parent atom first and then remove the charge from the highest energy level. So in our last example, we want to write the electronic configuration for Cl-1, meaning that there is a -1 charge, that there is an extra electron, and the normal Cl contains 17 from the periodic table. So let's write for the Cls normally. So 1s2, 2s2, next is 2p6, we already have 10, so 7 left, and next is 3s2, and next is gonna be 3p, and we are in total of 10 and 12, so we are left with only 5, so we only need to use 5 of the p's. And here in the Cl-1, we just need to add one more electron, so it's just gonna be the same thing here but the p will become 3p6 because we just need to add one more electron. So if I just copy paste this here, it's just gonna be 6 here, and that's it. It's really simple, and I mean, you just need to practice this a lot and you will become a master at it. So yeah. Also, if you have any questions, you can ask them in the comment section. I'll be more than happy to help, and thanks for watching.